Welcome to the another session in Frontiers in Safety. Today we will prepare the geometry of lithium-ion cell separated by serpentine flow channel. So the first objective is preparation of the geometry for lithium-ion cell separated by serpentine channel, generation of mesh, name selection on computational domain, applying the boundary conditions and visualizing the results. So welcome you all. Today we will see how to prepare the geometry for serpentine flow channel which involves lithium-ion battery. So this is the basic dimension of the geometry. So accordingly we are going to process this geometry with the help of workbench. So let's open the ANSYS workbench. We are going to use the design modeler, and whatever the geometry has been specified, so that we are going to proceed in design modeler. How to prepare geometry? We have seen one video which is related to the simulation. So as per the request, I am preparing the geometry video for the serpentine flow channel. So let's understand how it can be prepared. So you need to start with the workbench. So I'm using ANSYS 2023 release 1 version. So the workbench is open. So we'll use the fluid flow fluent option. First of all, geometry will be prepared with the help of design modeler. So I select the new design modeler geometry. So let's go back to just check the dimensions of the geometry here. So this has been separated by 23. These are the angle is 45 degree in between them, and this is a 5 channel. 5 is the is the width of the channel over here. So let's first set the units to So understand where you want to prepare the geometry. So accordingly, we are going to have it. So let's click on XY plane. So this is how the XY plane is there. So I select ZX here. So one by one, let's see. So first is 5 as a serpentine channel. So dimensions are 18. So diameter is 18. So this is the first cell. So we need to prepare the other also. So this one here. So angular dimension I will take this one and this one. it should be 45. So ensure that this is 45 and ensure the length also. So this one to be equal to 23. Yeah. So accordingly we have to proceed. So this is the first thing. We need to draw one more circle here with the same radius. Okay, so now one more circle, one more line I will draw. So this will come here. Again, this should make an angle of 90 degree, sorry, 45 degree with respect to this, and this angle should be. And the general dimension should be equal. Okay, so by default this will be equal to same. So this is what we have followed. So let's draw one more line. So it should be parallel to the earlier one. Only need to ensure that this is of 23. So one more circle we need to draw of same radius. Then we'll draw one more line. Now this line will by default will parallel to this. You can check it. So if you get this message, means it is you have done the same dimension. Now one more time draw the circle here on this. So if we have already drawn one, it will be easy for drawing the others. So let's say see this one parallel. Only need to ensure that this is of same dimension. So this is 23. So one more time draw one more line here. It should be parallel to this. Okay, again if you see some error which is coming out, so it means you have taken the same dimension, so you can you are on the right way. So you don't need to again take the same dimension. So that is how things works. So one more time here, draw a circle of same radius. Here draw a circle of same radius. So I will try to draw one more here. Ensure the dimension is 23. So this becomes quite easy because once one structure is prepared, it will be easy to proceed with the for the others. Yeah. So this is one more time draw a circle here. Yeah. So drawing here also. So in this way, I try to prepare 1, 2, 3. Okay, this is left. Yeah. So we have drawn 1, 2, 3, 4, 5, 6, 7, 8. So we'll go with the combination of 8 only. So it is similar, like you can enhance it to higher level also. Now this is related to the first circle which you have prepared. Now I'll prepare the another circle of diameter, say 28 here. So this will exactly touch this other circle. So why we do this one? Because we need to create the serpentine channel. So that's why I prepared the another circle. Now this circle should be same as this one. Yeah. So I prepare one more time. This is 28. So once one circle is prepared, it will be easy for us to prepare the other one. So now all of them we are preparing for 28. So let's have this is 28. This will also be equal to 28. So this one will also be equal to 28. So now we are just following the path how the things are done here. So For this case we need one more circle which will be on this side, will be parallel to this, and let's take the dimension that is equal to 23 again. We need to draw one more circle on this, two circles, one of this radius and other of the second radius. So this will be useful for us to get the channel, just like here in this diagram you are able to see this kind of channel which is up to this. Same way here the channel will be there, and that will be useful for us to proceed the channel which has been specified like this. So same way you may require this on this side also. So here I will prepare one more line, ensure that this of same dimension, let us say 23 here. So draw two circles again, one of 23 and second. So you this is the first one and this is the second one. Yeah, so these are the two circles. So what will happen when you draw this, it will be kind of channel which has been available here, and we say the way you are able to see this diagram, similarly it will be visible here. So now let's proceed with the operation which is called as trim, because we need to remove the parts which are unnecessary. So for this I will follow one part. First thing, that is I will draw one line here, vertical line. Similarly I will draw a vertical line here, so that I will have a reference line which can be uh, considered as a channel. So let's trim out this part which is not necessary. Let's trim out this, let's trim out this one, here this one. So we are actually trimming the sketch available here so as to get the required pattern we required. Okay, so now you might be getting a certain highlight of what we are doing. So this one I will eliminate, this one I will eliminate. So this is also not required. You may delete this, deletes this also, this also. This is not required, this is not required, this is not required, this is not required, this is not required. Say this is also not required. So whatever is not required for the geometry, we are just going to trim out. So this one here, whichever is the unnecessary part, that we are going to remove. So try to ensure that you are deleting all the things which are there, otherwise there are chances of errors in the geometry. So ensure that you are doing this properly. The edges which are not required, so you should delete that. So this is also not required. Now let's check if something is pending. Yeah, it looks almost we have trim out all the unnecessary things. Just check it if anything is pending. If you want to check it, just click on this. This will also give you some highlights of what, yeah, this is one thing which is pending. So go back to your sketching, modify and trim this again here. So now what I will do is I will trim out this part also, because I am preparing the sketch, and I will tell you how this is important, because later on when you prepare this entire sketch, that time you will understand why this operation has been done. Here, this one, and this one. Now one more time, just check it, the geometry from the sketch. So this is how the outer sketch has been prepared. There should not be any extra edges available, so otherwise there are chances of making the errors. So let's more just one more time, just check it. If, yeah, this is one thing which was left. Yeah. So now check it. So this is the entire sketch which has been prepared. Now I will do one operation which is called as extrude. So we have prepared the sketch. Now I will do an operation which is called as extrude. So select sketch 1. Instead of add material, I will make it frozen. Depth I will take it 65 here, and let's make it generate. So now you will see how the pattern has been prepared. So this is kind of channels along with the cell, the geometry which has been prepared. Now the next task is to separate the cells from the casing, or separate the cells from the channel. So what I did need to do is, I will uh, add one more sketch here. Go to your ZX plane, make it look at. Now what I will do is I will prepare one more sketch here. So this is sketch 2, we are here. So I will prepare a circle from the same center for all. Back. So I prepare same circle for all. Here. Yeah. Now we have generated a few circles in sketch 2, as you can see here. Ensure that it is done for each and everything. Okay, one more time. A few things are there which is not trimmed out. So this one is not okay. So ensure that everything is been done correctly. Yeah. So we are now on sketch 2. So let's make it there. This is your sketch 2. Now I will do one more time one operation which is called as again extrude. I will go with the sketch 2, make it apply. Instead of add material, I will make it slice material on the same 65. Now what will happen here, you will see the channel is separated. Then these are the individual cells you are able to see as a solid. So this is how the separation is been done when we have prepared the sketch. First what we have done is we have prepared the entire thing as a channel along with the cells. Then we have prepared, we can say prepared one more sketch, that is circle, and we have extruded so that what happens, this channel is been separated out with respect to your cells. Now we'll one by one define the cells over here. So you can give the naming also, like cell 1, cell 2, cell 3, and so on, and accordingly the further operations can be done. So now this is the casing we have prepared, as well as the cells we have separated out. Now important thing is to proceed with the channel, because the channel will be hollow from inside as the fluid is flowing. So we need to create one more plane. Now from where we need to create, I will select now face. So here I will select the face. So this is the face I have selected, make it apply. So what we have now, I have created one plane on this place over here. So this will be useful for us now to mm, make this as a somewhat hollow. Now the thing is, you can make it hollow by with the help of slice operation also, but filling the fluid will be somewhat tricky because the geometry is quite long and the complications can be there in the geometry. So the easiest way to remove the complication is just by filling the fluid inside, or we can say having a channel which is sliced within the geometry. So let's do one thing. So again I'm going back to your this plane here. So I just look at this again. I need one more operation over here. So that is again I am going to prepare one more sketch. So this is your sketch 3 now. So one more time I prepare a circle which is being passing through this, but now the diameter of the circle which I am taking is say I need first one 18 as your cell diameter. So this 5 is the your channel. So 18 plus 5 you need it 23. So it will be passing through somewhere here. So based upon this I am going to prepare one more time a similar sketch. So create one more circle. Now the dimension will be of 23. See what we are doing different here. We are preparing another sketch. This is for we can say the slice operation, or the we need a channel which is hollow from inside, so that's why we are following this operation here. Yeah. Similarly we might need it here itself also, and on the same side we might need it this here. Sorry, this is not proper. Yeah, so everything has been done properly. Now again you need to go with the trim operation, because we need only the important part of it, we don't need everything on it. So that's why we are going to remove the unnecessary parts which are not required for this geometry. So let's trim out this one. What we are trying to do is we are trying to prepare a path so that we can prepare a fluid zone inside. So that will be the easiest way of doing it, because selecting the internal cavity is somewhat difficult. So let's have this. Ensure you are doing it properly, otherwise there are chances that there may be errors when you prepare the geometry. Okay, so for just checking, go to your sketch and see whether it is in the right way or not. So whether check out if anything which has been pending, otherwise there are chances that the things might not work well. Okay, so this is how the things are done. Let us say for the flow path we are generating. Now one more time I will go back to the plane 4 which we have generated. So just look at your plane 4. Okay, I will edit this, say this, make it apply, and okay, so I selected this as a face. Now I will look at this plane here, and I will try to okay, just carefully look at how this is. Now I will prepare one more sketch in the plane. So let's prepare a sketch like a rectangle here. So see your face, this is your okay, this is your face, and on this face we are trying to prepare a sketch over here. So I say it is always show sketch. Yeah. Now go to the dimensions for the sketch here. I take from this say general dimension. So this is around, I will take it 60. So this one I will take it, total is 5, so I will take it 3. Now the important thing is, go to the dimension. Okay, so this is I am totally 65. We have taken 60 as the channel dimension, so I will take it 2.5. So it will be slightly below. Now same way I had to adjust this and this. So this one and this one. So I will take it this as a 1, because total is 5. We have taken is 3. So it will be equally divided, equally separated in both cases. So let's say this is the sketch which is we prepared. Now what I will do is I will do the one operation which is called as the we can say we can follow this kind of a sweep operation over there, or we can, yeah. So we have prepared the sketch here. So let's sweep and select the profile. So profile is this, make it, path will be your sketch 3. See, this is a path, you can see here the path. This is your profile which you have generated. Instead of add material, I will make it slice material, and just it is throughout. So now you see the channel, we say the channel has been created with the fluid flow inside. Okay, so you can see now, earlier it was just a single geometry. Now what we have is, here we have a channel which involves some kind of thickness also. So let's see this one quite carefully. So this is the second. So I will hide all the other bodies. So let's say, so this is how this casing has been, and along with the flow channel which has been available. So what is this? I will make this as a fluid here and generate. So this is your casing and this is your fluid which is flowing. So you may specify this as a fluid. Okay, so I will make it now. You may rename this as, say, channel casing. Okay, so you can say this is a fluid and this is your channel casing. So I will show all bodies. Now you can understand how the channel has been prepared along with the cells. So individually, one by one, I will rename this as cells. So let's rename this, say, as a cell. This one also as a cell. So cell should be solid. You understand the properties which are below also. Here this is also solid. So whichever the solid portions are there for cell, I will just specify this with the help of cell. And here, so now I will make this as a one part, so that we don't need to, okay, we don't need to select apply many boundary conditions as far as when we proceed for the post we can say setup. So I will put here as a name as cell. So these are your cells, this is your fluid which is flowing, and this is your channel casing. So channel casing can be given separate material. The fluid is the separate, and you can have the cell, you can specify the cell as a separate material. So likewise this geometries can be prepared. So first of all, first section, that is preparation of geometry, has been done. So let's save the work so that we can access it later on. So yeah, so go to your how to prepare geometry of serpentine channel. Geometry of lithium ion batteries with serpentine flow channel. So let's open. So how to prepare geometry of lithium ion. Okay, so I will save this work so that you can easily access it later on. Now it's time to now prepare the mesh. So this part has actually been done, but just I will show you with some edit. Meshing is uh, the critical thing is how you are going to specify the name selection, how you are going to specify the inlet outlet. So that is also important when you proceed further. It's taking time. So the meshing is open and you can now see how the object is here. So I just generate the default mesh first, just to visualize how it is there. I just change it to 0.001, so it make it somewhat fine. Let's make it generate, so that will be quite better at each and every section of your we can say cell, as well as the channel, as well as the flow portion which has been there. So this looks to be a better one. I may not say it is too fine, but it's okay to just understand the things. So let's proceed further with the important things which is there. So let's specify this one as your inlet. Create name selection, I put here as inlet, then I put here as the outlet. So inlet outlet we are done. Now I will just hide the channel casing, so that channel casing and fluid, so that I can easily select the faces to apply the boundary condition later. So I have selected all the faces for your cells. Go to the create name selection. I will say here as a cell boundary. So we are done inlet, this is outlet and cell boundary. So let's show all bodies. So this is inlet, this is outlet on the other side, and this is your cell boundary. In addition to that, you may specify the casing also. So I hide all other bodies. So this is how the casing is there. So I can give the names to this also. Carefully select the things here. Do not select the internal part. So here also we have to select only outer, not an internal one. Yeah. So make it name selection over here. So you can say it is channel casing. So if you have different material for the channel casing, in that case it's very important to specify this, so that you can give the different materials on it. So let's make it update. And okay, so you see this message, mesh translation to fluent successful. you can close the meshing and go back to your workbench window. So let's open the setup now. Specify the number of processor with your computer. I'm putting it myself as a 12. In your case it will be different. You can check it in the task manager how many processors simultaneously can be run by your computer. So I will just apply the boundary condition and I'll just proceed with the kind of simulation, and then we'll see uh, one last part that is related to the boundary condition. So it can take time depending on your system configuration. If you have to take very fine mesh, then probably the time required will be more. Okay, so some issue occur, so I had to put it exit. Okay, Fluent failed to validate, so one more time I will open. Let's make it okay here. Sometimes this issue may occur, so you may just exit and come back here, so that we are seen here. Maybe sometimes you are not connected to internet or somewhere, so this can happen. So just observe the arrows, it is as per the required direction or not. If they are, accordingly we'll proceed. So first of all, set transient, I put it minus 9.81 here. Then go to the model, I will put energy equation on, this is here. Then in case of K epsilon, enhance water treatment, thermal effect and curvature correction. So we'll make this. So we are just dealing with the thermal analysis, so that's why I'm using this energy and the viscous K epsilon model over here. So go to the material. So what material we required? Let us suppose we need fluent here. The fluid we required, say let us say water liquid. It may be any other liquid. I just for the standardized I will put here as water liquid. You can use any other, or you can apply the bond, use your different working fluid also. Now let's say nickel, aluminum is already there, so make it close, make it close. So you have nickel and aluminum. So nickel I will be using as a cell material, and aluminum will be a kind of casing which is been available here. So let's go to the boundary condition, put some value of here at inlet. So let's say 0.5, I put velocity magnitude, make it apply and close. Then cell boundary contact region which you are observing. So that is what you need to put as your boundary condition. I am putting here as a temperature as a boundary condition. You can put heat flux as a boundary conditions also. Now let's say this is nickel, make it apply and close, make it apply and close. Same way for other also, you need to put this one. I need to put temperature here. I will put it 323. As I said, you can use the heat flux also. I am specifying this as a nickel. By default, it is aluminum. So when you go for channel casing, by default, it will be aluminum. So you don't need to go and change this over here. So this is how the boundary the thing which we have applied. One more where the boundary condition will apply is your cell. So temperature, I will put it nickel and put it 323. So make it apply and close. So reference values, let's start it from, tell the computer from where we need to start. I say inlet here and is a fluid. So go to the initialization here again, let's say it is inlet, make it initialize. Okay, so now go to the calculation activities, put it to around 20. Let's set the solution animation. So what you want to visualize, let's say I want to visualize the contours of temperature, a total temperature. So I will put here is a total temperature. I will select all. If you want, if you don't want exponential scale, so you can select as a float option and then close, make it save display, then close this, click on the contour and make it okay. So this is a float scale, otherwise you might see the exponential scale also. So it depends, whatever you want accordingly you can put it here. So adaptive I will put it say around 200 here, or let's take it 100 first for our sample calculations, make it 0.5, and let's start calculating. So here, so you'll see some residual which is coming out, and after some few seconds you will be in position to understand how the heating and other things are being carried out. So contours of temperature we have set, scale residuals it will be available. So this is one way. Now your window will open with the contours of temperature after few seconds. Yeah. So this is how you can identify the pattern. The cells are getting heated. So right now we don't have much of we say the heat which is available at the central section. Now you see it has increased. So likewise, when you increase the number of time steps, so accordingly it will go on to have more heat distribution to through this channel. So you can see how the distribution is been taking place, the temperature distribution from the cells to the casing, and then ultimately it is heating up the fluid which has been present inside. So this is how the simulation that can be done. We have started with the preparation of geometry. Right from the geometry we have prepared, and this is how the simulation is there. And the last part which is related to post processor we is already covered in the previous video. So this is all regarding to how to prepare the geometry and how to apply the boundary conditions and how to visualize the things in the we can say post processor and the setup. So let's